Hello, this is the lesson for September 9th. Start out with the date. We're going to pick up right where we left off, talking about northern lights and sunspots. Okay, I don't have a catchy title for this one and no theme music. This is a relationship between Aurora and sunspots. That'll be the first thing we talk about, and then I'm going to spend some more time talking about the sunspot number and getting you ready for the rest of the short week we've got. All right, the last thing I left you with on the lesson from the 8th was Aurora, which are also called the northern and southern lights. People here in Minnesota, southern Minnesota, will ask when I talk about northern lights, well, what time of year do they happen? Because a lot of times they think like, well, maybe I just missed it. Or maybe it's in the wintertime when I'm inside and it's just, they think they've been unlucky. It's not really, that's not what's causing most people to miss northern lights. Northern lights are more common near the north and south poles. And since we are here in Albert Lea in southern Minnesota, we don't see anywhere near as many northern lights as people in northern Minnesota. Okay? If you've been lucky enough to see northern lights when you went on vacation up north, you might think, well, that's because it was that time of year. No, it's because you went farther north. Okay? The farther you get away from the poles, the less often you'll see northern lights. Also, northern lights, southern lights, the aurora are more common when the sun is active. So I'm going to write all that down, okay? So aurora are more common in or near polar areas. In other words, they're less common as closer you get to the equator, okay? And the other thing is, aurora are more common when the sun is active. As in, lots of sunspots. All right. Yesterday we drew just a sketch of sunspot cycles. I'm going to do one again here. Okay. Okay. They're about 11 years apart. Approximately 11 years. 11.1 is the average. Okay, next. This is called solar minimum. And the top would be solar maximum. Make that be an arrow. All right. Now, I'm going to take you on a little bit of a tour here with the camera. And at the end, I'm going to make sure I tell everybody again how to flip videos if the camera and YouTube combo gives you a version that makes you turn your head sideways, on how to flip the video so you don't get a stiff neck or have to turn your Chromebook on its side. Okay, so here I am picking up the camera. Now, I'm going to tell you a story from my past. All right. Way back in the day, before my wife and I had kids, I got a hold of the data for the sunspots for every month. And I asked my wife one time, I said, hey, Kelly, mind helping me do a project? She said, sure, no problem. I didn't give her any specifics, okay? And she said, okay, what do you need me to do? I said, well, here's this list of numbers. I just need you to read them slowly to me while I make a graph. She went, oh my goodness. She said she'd She would do it, but she'd never do it again. So we had to keep on moving. It was 600 dots that I made. She read them to me. And I'll let you zoom in here. We started in the 1940s. Okay. This is one sunspot count per month. Okay. Not per year, per month. Okay. There's the cycle that peaked in 1957. There's one that peaked in 1969. Now I have to walk around my desk. Okay. Maybe you can see it. This is called the sun's heartbeat. Okay. Here's another. I went and walked around my desk. Here's the 1979 peak. And then the 1990-91 peak. The 2000-2001 peak. And then the wimpy 2014 peak. See how jagged it is? That's because those are monthly numbers. If you took all 12 months of a year and added them up and divided by 12, you could reduce that down to 1 dot per year. And then the sunspot would be a lot more smooth. Imagine if I did it every day. You can find on the internet now the numbers for every day. Imagine how jagged that line would be if there was 30 or 31 dots in between each of these little spots. Okay? Imagine, my wife would never say yes to that. I wouldn't even ask her. Okay? That'd be nuts. Now, I'm going to walk to the back of the room, actually to the side of the room. Stop real briefly here. Here's a picture of the sun, the way it looked in March of 2001 near the solar maximum of that cycle. And then 4 years later, solar minimum. There's like no sunspots, maybe one. Okay. Look at the difference between a maximum and the next minimum. Okay. I'm going to walk over here. All right. These are just some sunspot pictures or sketches from times when I made a big deal of them since I've been in Albert Lea. This, at the time, this was in May of 1998. It was a nice springtime, and it was a Sunday night, and I was looking out my window, and a strange vehicle pulled up into my driveway, and two people jumped out of the car, and I had my window open because it was a nice spring evening, and the person who jumped out of this passenger side of the car yelled, "Mr. Fiskus, Mr. Fiskus, Northern Lights, Northern Lights." And it was one of my current students and his mom. They had driven home from the cities, and the Northern Lights had kicked in, and he'd spent 20 minutes on the way home from the cities convincing her they had to stop by our house to let me know. This is before the internet. Nobody knew my phone number or anything like that. He rightfully convinced her that I wanted to know this. Okay? I grabbed our dog. My wife and I jumped into our car and followed them out into the country, and we spent hours watching the most amazing northern lights of my life caused by this group of sunspots. By the way, that student got an A in the class because of that night. Okay? He gave me the best northern lights of my life. I think he was going to end up with a B. I gave him an A because that was an amazing thing. I would have missed it if he wouldn't have convinced his mom to stop. Okay? All right. That's about 60 sunspots on the sun in that picture. Okay, this one. This was February of 2000. This is about what 110 sunspots looks like. Okay? When I printed this off the internet, one sunspot right there wouldn't fit on the picture. But that's what 110 sunspots looks like at one time. Okay? You're like, that's not 110. If you look closely, that's probably like 20 some sunspots right there. They count the little tiny ones too. Okay? They're all over the place. Okay? That's what the sun looks like at solar maximum. Okay? Now, here is the count on this day was about 115. There are so many sunspots in that group. That isn't 2 or 3. That's dozens just in that one group I'm zoomed in on. All right. Now, I made a big deal out of the northern lights that turned the sky red in North Carolina. This is the group of sunspots that did that. That was late March of 2001. Look at that, all those sunspots. Okay, now this was March 28th. Notice that this sunspot group, as the sun turned toward us more, look at the change. The sunspot group got bigger and bigger and bigger. Okay, this was the next day, the 29th. Okay, that's what the sun can look like when it is all wound up with lots of energy. Okay, this is a different day. This was late September 2001. Look at those sunspots. Okay, now I've taught for Riverland. I taught Intro to Astronomy several times, and one of my students gave me this when they saw some northern lights. A great description of what they saw of the motion and a great sketch. I kept that for my scrapbook, so to speak, my notes on northern lights. Okay, coming back over here, here's the sun with sunspots that I drew on there. Those are supposed to be like Earth-sized. Now I'm going to walk back over to my usual spot and do a little bit more. We're at 11 minutes right now. Okay. All right. Let's separate this out. Now, the scavenger hunt I assigned you last week is due. I need you to be able to hand that in next time I see you in class. And remember, you get points for the effort, not getting the answers right on that. Okay. One of the most important things in the scavenger hunt was BBSO. I should have called your attention to BBSO on those pictures I just showed you, those black and white pictures that I printed off the internet. Those came from BBSO. Okay? That stands for Big Bear Solar Observatory. It's a very important place. It's named for the lake that it's at. It's located at Big Bear, California. I'm just going to write located at Big Bear Lake, California. Here's why it's there. When NASA was looking for a place that it could have very clear views of the sun, they wanted a place where they could get rid of as many heat waves as possible, the stuff that makes the air unsteady and hard to look at the sun and get a clearer view. Okay, they found a great place in California. This is NASA's Solar Observatory. Here's what's neat about Big Bear. The lake is up on a mountain, which is an unusual place for a lake. Okay? So picture a very large mountain and a great big lake up near the top of it. Okay? Now, I'm speaking to Minnesota kids. I'm going to assume most of you, not all of you, I'm going to assume most of you have been on a fishing boat or just on a boat on a lake in the summertime. Now I'm going to call your attention to something you may have never noticed. When it can be a blazing hot day and the boat ride just feels awesome. But have you ever noticed when you were out on the lake you didn't see any heat waves? There weren't any heat waves. The water was absorbing heat from the sun. It wasn't giving it off. Okay? So that's the key. The reason this observatory is in a lake on top of a mountain is no heat waves. All right. Tell yourself, large lake on top of mountain, no heat waves. equals steady view. All right, next thing. Okay. I'm going to stop there. I made a promise I was going to tell you how to do this. All right. Viewing tip. For Fiscus YouTube videos that get flipped. You don't have to write this part down if you can just remember this trick. Viewing tips for Fiscus YouTube videos that get flipped. Use Control and the Alt keys and the arrow key. On the Chromebook, it looks like this. And it's just these arrows on a PC. All right. I'm going to end that there. That's 16.5 minutes. And there will be another short video to watch. It's about the Sunspot Cycle. It'll be linked in Google Classroom. See you tomorrow or Thursday, and make sure you bring your scavenger hunt sheets in. You can still do your scavenger hunt. It's on the Google Classroom.